This is question 5. So it says, use the substitution x equals u squared plus 1 to show that this is equal to this, where p and q are positive constants to be found. So I know I need to use substitution, and I'm looking for positive constants. So if I have x equals u squared plus 1, then dx du is going to be 2u, which means that I can write dx equals 2u du. Let's look at the limits of integration. So I had 10 and 5, so they were x. So 10 is equal to u squared plus 1, and 5 is equal to u squared plus 1. So then I've got 9 equals u squared, and because I'm looking for a positive constant, I'm going to take the positive value of this and have u equals 3. And then I've got, take away 1, so I've got 4 equals u squared. I'm going to take the positive 1, so u is equal to 2. So they are my new limits of integration. Cool, so let's carry on. So I had the integral of 10 over 5, 3 dx over x minus 1, 3 plus 2 root x minus 1. So I now know that I'm integrating between 3 and 2. And I've got 3 dx is now 2u du, 2u du. I've got an x minus 1, so that's a u squared plus 1 minus 1. 3 plus 2 square root of x minus 1, which again is u squared plus 1 minus 1. So let's keep going. So that's 3 over 2. That gives me 6u du. U squared plus 1 minus 1 is just u squared. We've got 3 plus 2 times the square root of u squared. I'm going to do some cancelling out, so cancel out this 2 and the u with the u squared, leave u on the bottom. So I've got 3 over 2, 6 du, u, 3 plus 2, and the square root of u squared is just u. So that is exactly what we were looking for. I'm going to be really clear. I'm going to write now that p is equal to 2 and q is equal to 3. Lovely. So let's look at part B. So it says, hence, using algebraic integration, show that this is equal to LMA, the natural logarithm of a, where a is a rational constant to be found. So I'm using algebraic integration and I'm looking for a rational constant. So the question says hence, so I know I can use the first part. So instead of integrating this, I'm going to integrate this. So I've got the integration of 3 over 2, 6 du over u, 3 plus 2u. So that's a bit tricky, so I'm going to use partial fractions. So I'm going to think about what is 6 over u, 3 plus 2u, written as something over u plus something over 3 plus 2u. Well, this implies that a times 3 plus 2u plus b times u is equal to 6. So that's 3a plus 2au plus b BU equals 6. And there's no u's on this side, so I know that this plus this must equal 0. So I know that 2a plus b equals 0. So that means that 3a must be equal to 6. 3a equals 6. So to solve that, a is going to be equal to 2. So let's sub that back in there. So I've got 2 lots of 2 plus b equals 0. So 4 plus b equals 0 means that b is going to be minus 4. So what I have as my partial fraction is that 6 over u, 3 plus 2u is equal to 2 over u minus 4 over 3 plus 2u. Lovely, so let's integrate that instead. So I've got the integration of 3 between 3 and 2 of 2 over u minus 4 over 3 plus 2u du. So what's that going to be? Well, if I integrate 2 over u, I'm going to get 2 ln u. And if I integrate this, well, it's not as easy as the other one, but I know that it's going to be minus 2 ln 3 plus 2u. So I was going backwards. Differentiating this gives me 2 over 3 plus 2u. I've got a 4, so I've got to times it by this 2. And that's all between 3 and 2. So putting these limits in, this gives me 2 ln 3 minus 2 ln 3 plus 2 times 3. So 3 plus 6 is 9. That's a bracket. And then I've got 2 ln 2 minus 2 ln, so then 2, so 3 plus 2 times 2, 3 plus 4 is 7. So I've got this. So let's use the log rules. So this gives me 2 ln 3 over 9 minus 2 ln 2 over 7. Keep forgetting my brackets. And that is, we're running out of space. Let's get some more paper. So that would be 2 ln third minus 2 ln 2 over 7. I think I did something wrong. No, I haven't, that's fine. Equals 2, I've got third over 2 sevenths. I'm going to figure that out. So I've got third divided by 2 sevenths gives me 7 sixths. So I've got 2 ln 7 over 6. And then the question says they want it in this form here, so I don't want a number in front, which I've got, but I can carry on using my log laws, and I know that this is the same as ln of 7 over 6 squared, which is ln of 49 over 36. So I've got it. This is a rational number, and it's a constant, so that means that a is 49 over 36. And I am done.